fresh look at the subject and the way of analyzing it. And I began looking at data in the Northwest and the rest of the West Coast and other places, and using Pat's approach, and became convinced that Pat was right.
What was Pat's premise?
Pat's premise was that the effects of changing CO2 on climate would be manageable and benign. That the influence of changes in greenhouse gases would be minimal. We might not even be able to measure it, and it was really he didn't really say it was a waste of time and money, but certainly implied that the effects of significant CO2 control would be rather insignificant in the climate system, because he felt that CO2 did not exert a very strong influence on climate, and that climate change varied mostly because of other kinds of natural changes. And as I analyzed the data over a couple of years, it made a lot of sense to me, and began to really coalesce into a new way of looking at the world, and yet it was a way that many people disagreed with. And again, it's this emotional thing that people get very altruistic. They come up with certain belief systems, and if you say anything that would violate those, they get very upset. And that's the only way I can describe what happened to me, was that I was set upon by colleagues and other people, because by not agreeing with this whole thing, this notion that CO2 is wrong, then I was somehow a bad guy. I think ultimately it's really about control. And if you to control CO2, you're really controlling how we use energy. And if you control energy, you control life. So ultimately, I think a lot of it is about control, and control by government of individuals. And so being one who doesn't always trust the workings of government, it makes me a bit suspicious.
I think it's pretty interesting to look at the language that's now been established regarding this whole thing. A carbon footprint, a carbon trading system, the involvement of J.P. Morgan's architect for derivatives, who's part of the carbon trading system. It's disconcerting how everybody's villainized who dares to question or look at any of this. My question to you is, on a scientific level, how much CO2 do you think is released when a volcano erupts?
I've seen various figures, and I guess the bottom line is a lot. Compared to human emissions, probably on an annual basis, probably not that much. I've seen figures for the Iceland volcano that suggested that this was, years worth of emissions from humans, and I don't think that's necessarily true. But certainly volcanoes have a strong influence on climate. Probably not so much from the CO2 standpoint as they are from just the amount of dust in the atmosphere tends to block sunlight. And it's especially true with tropical volcanoes, such as Mount Pinatubo in the Philippines in the early 90s, El Chichon in Mexico in the early 80s, and then way back, Tambora in the early 1800s and Krakatoa in 1883 were huge volcanic eruptions with a lot of dust in the atmosphere, and they caused a global cooling that lasted for some time. So certainly volcanoes have a significant influence on climate. Mostly a cooling influence.
When you refer to human emissions, what does that mean?
Carbon dioxide is a product of combustion, and for pretty much any kind of combustion of a carbon-containing material. Now, that can be burning wood, it can be gasoline, coal, natural gas, any of the hydrocarbons. When they're combusted, one of the byproducts is carbon dioxide. Carbon dioxide has been going up for really throughout the Industrial Revolution. The pre-Industrial Revolution amount of CO2 in the atmosphere was 250 or so parts per million. That's 0.02% of the atmosphere by volume. Right now, it's at about 390 parts per million. So there's been an increase. And at the same time, temperatures have gone up. So people say, well, see, CO2 went up and temperatures went up, and that's that. Al Gore says that all the time. The problem is the beginning of the Industrial Revolution occurred at a time known as the Little Ice Age, which was a lot colder globally than it is now. Glaciers were down in valleys, and there were a lot of crop failures because colder temperatures tend to be rather detrimental to agriculture. So that was just a cool time. And if you start a trend at a cool time and end it at a warmer time like we're seeing now, then you're going to see an increase. And so people say, well, CO2 went up and temperatures went up. But if you go back 1,000 years, you come to a period that's usually known as the medieval warming or the climate optimum of the Middle Ages that occurred centered around 1000 AD with a couple hundred years before and after. It was a time that was comparable to today in terms of temperatures, and crops really flourished. Civilization was very happy. Greenland was settled, and there was agriculture in Greenland, and CO2 was a lot lower than it is today. So whatever caused the warming 1,000 years ago, it wasn't CO2, and I think whatever caused the warming now, it's mostly not CO2 either.
I have another question for you. Why is it, if you go to iceagenow.com, he tracks how the Earth has been cooling. It's a huge clearinghouse of information of what's going on in terms of climate all over the world for a long, long time. How come it is that the Earth, from a data perspective, is cooling for the last 10 years, but most of the conversation is about how it's warming? I don't get it.
I don't get it either, Kim, and I know that NASA and maybe the National Climatic Center have declared that 2010 may be the warmest year ever. Of course, we're not even halfway into 2010, so it's a little bit early to declare that. But there's so many issues involving how you take the temperature of the Earth, and I think, frankly, to take a single value for the temperature of the Earth with all its variety is a big mistake. I just don't think we can do it in any kind of a decent manner. I think we have to look at individual locations and then somehow come up with a better way of identifying this. But there are a lot of people that believe that we are moving into a cooler period. Have already moved into a cooler period, and I'm one of them. We're seeing unexpected reduction in radiation from the sun, fewer sunspots. The solar physicists are kind of scratching their heads wondering why the sun is so inactive now. But I think that's one of the factors that will influence temperatures over the next 20 or 30 years, and I think they will continue to be on the cool side. The other factor that I think is huge is the tropical Pacific. The tropical Pacific, from South America on the east to the Indonesia on the west, let's say 10 to 15 degrees north or south of the equator, dominates world climate. This is an area called the Pacific Warm Pool, and it is the largest source of heat to the atmosphere of any place on Earth, and changes in the tropical Pacific literally affect every part of the world. And in a nutshell, when we get an El Nino event, we tend to see warming, global warming. And when we get a La Nina event, we tend to see global cooling. Now, over the course of time, El Nino and La Nina events happen about as often as each other, about each one about the same frequency, but they tend to be bunched up into periods of about 25 years, where you'll get maybe a 25-year period with mostly El Nino events, and then 25 or so year periods with mostly La Ninas. If we look at the 20th century, there were four pretty distinct periods. The first, say, 1900 to about 1920 was mostly La Nina periods, and the temperatures were rather cool. From the 20s to the mid-40s, we were in a mostly El Nino period, and that was a very warm period. In the U.S., it was the warmest period that we've seen in the last 100 years. And I think it was because of all these El Ninos. From the mid-40s to the early 70s, we were back in a mostly La Nina period, and temperatures were much cooler. from the mid 70s to the late 90s, we were in an El Nino dominated period, and that was really the